Hey guys, what's going on? Welcome back to the Your Forest podcast. This is going to be a good one. This podcast is brought to you by Greenlink Forestry. They provide resource inventory services in the province of Alberta. And yeah, they're flying digital imagery. They're getting digital imagery flown, I guess, with LiDAR and a bunch of other technologies. And they create a detailed inventory map of the land base, and they do it the best. I'm kind of biased. I work for them. But I could say that they're raising the bar. They're trying to give as much information as possible. They're going beyond the spec, beyond the, what the government says you need to do, and they are doing more than that. It's awesome. I feel really proud to be a part of this company. We're doing really great things, and yeah, they do a good job. Today on the podcast, I've got Chris Olson. He is the CEO for a company in Alberta here. It's called Innovative Reduction Strategies, Inc. And they create a biochar product, and we'll get into all what biochar is. But yeah, he's a really knowledgeable guy. He's trying to get his company off the ground, and he's into some really interesting technology. So yeah, he's an awesome guy. I really like talking to him. We got through a lot of information, all very on topic. So I was really happy about that. Unlike some of the tangents I've gone on a previous podcast, this one was on point. So yeah, so here's Chris and I. So yeah, so I'll just get started. Maybe let's get right into it. What exactly is biochar, and how did you come about interested in this? How did you start it? Yeah.
Okay. So biochar is a pretty broad category. Kind of at the simplest level, biochar is
just a little closer to your face there. Yeah. Just lean it right into it. You can lean back. Just lean this pull the whole system back into you. Yeah, there you go. Whole thing moves.
So biochar is essentially a carbon-rich product that is derived from biomass and is thermally treated in an oxygen-deprived environment. So you produce biochar through the process called pyrolysis, which our system runs slow pyrolysis, so about 500 degrees Celsius, about a 86 to 90 minute retention time or residence time. Okay. And what you end up with is predominantly a carbon-based product, very similar to like a charcoal.
Right.
Biochar denotes that it comes from a biomass, but people in the biochar space would say that to call something biochar, it has to be derived from biomass, and it has to have a land application, so as a soil conditioner or something along those characteristics. In the broader sphere of things, biochar or an organic charcoal product has a whole litany of applications beyond just soil conditioner or soil amendment. But depending on who you talk to, they would say, well, that's not necessarily biochar. So the very narrow definition would be from biomass, thermally treated, carbon-rich product for land application.
Okay, so when you say biomass, to have char, you need to have something to burn, right? So generally, it's gonna be biomass. So what do you mean by biomass? What separates that from other things that might burn?
So what our system runs on is wood residue. So we actually take some material from a sawmill in Drayton Valley.
There you go.
Kiln dried, really quality chips.
Yeah.
But you can really do it with almost any type of biomass, like agriculture, forestry residues. So one of the things that we wanted to look at was doing hemp stalks out in Drayton Valley as well.
Gotcha.
So industrial hemp stalks.
They have hemp farms out there?
Yeah, they've actually, that's a whole nother conversation, but the economic development guy for Drayton Valley has been pushing industrial hemp out there a lot. So there's a lot of guys, I've been at a few workshops there, that's something that they're angling for.
That's sweet, actually, that's cool.
Yeah, they've got, part of the BioMile out in Drayton Valley has a biocomposite plant. So they're doing, hemp composites for, they actually have a contract with Toyota for door panels.
Yeah, I was just talking about that in the last podcast. Cool. I think Ford, the first ones were made out of hemp, the side panels and stuff. It's crazy how they can make it that strong. It's interesting.
Yeah, it's a great fiber. Hemp's one of the best things I think we can use, which we don't use enough of. But in terms of biomass, really the kind of the limitations for pyrolysis are moisture content.
Okay.
That's a big limiting factor. And then outside of that, depending on what kind of characteristics you have in the feedstock or in the biomass will dictate to some extent what your end product is.
Okay.
So like a hog fuel with more, bark and green stuff coming out of, say, a sawmill, that'll end up with a bit more ash in the end product.
Okay.
You're better off to avoid that.
Yeah,
but again, it depends on the application for what you're kind of making your biochar for.
Gotcha.
Different applications require different things in the end biochar, and that's why there's such a broad, definition for biochar realistically.
Right. Okay.
But yeah, pretty much anything that you could apply heat to,
you could make
in a biomass space. Yeah, and one of the things that kind of the thing that initially got me looking at the pyrolysis technology had more of a waste management angle to it.
Okay.
And I was working with a waste hauling company out of the Edmonton area, and I was finishing my second year in the alternative energy program at NAIT.
Mm-hmm.
And in our fourth semester, we did a project utilizing an updraft gasification system, which is similar to like flash pyrolysis, just kind of on one end of the pyrolysis spectrum. And what we did with that was looking at running mixed construction and demolition waste. And the kind of the express goal with that project was just to reduce waste. So not really produce a quality biochar, but through that work, we kind of crystallized the idea that a lot of the waste, especially here in Alberta, that we take to landfill, construction and demolition waste, has a huge quantity of good quality wood material in it.
Right.
So if you could take that material, shred it, and produce any value-added end product, even if it's a biochar that's just an absorbent or an alternate daily cover for landfills, there's a lot of value there.
Yeah.
And, from the environmental standpoint, because you're not actually combusting the biomass through the pyrolysis process, it's in the absence of oxygen, so you're indirectly heating the material.
Right.
You're
so
locking. There should be no emissions.
Right. There should be no carbon
minimal.
emissions.
Yeah,
right.
exactly.
Minimal carbon emissions.
The carbon. So our product that was tested by Initech Alberta, the research arm of Alberta Innovates, out in Vegreville, the product that we made had about 82% carbon.
Okay.
So the solid end product that you're producing is a really carbon-rich product. So, of course, you don't have that carbon available to make CO2. So that minimizes the emissions. So there's value in that as well. And, if you just throw wood in a landfill over time, it's going to decompose. You're going to get those emissions. So locking it in an inert carbon that, there's evidence to show in the Amazonian basin, the terra preta that exists there has held that carbon in its structure for thousands of years. So, somewhat anecdotal, I guess, at this point, but there's a lot of research going into that to show like how long is this carbon actually held in biochar. That's
amazing, actually. That's good to hold on for that long.
Again, kind of anecdotal, but I've read articles of indigenous people in that area digging up the terra preta that's buried now and using it as fertilizer actually in local markets.
That's working. That's awesome.
Yeah, so it's there's a lot of value there. In the ability to sequester the carbon and just in the process itself. But
so the terra preta is like a naturally created biochar, I guess.
They made it, so they did slash and burn. And
I see. Okay.
You can get it to produce biochar. You can get as simple as just like a metal kiln. And stick it in the ground in the right way.
To get rid of the oxygen somehow.
Yeah, control the oxygen flow. I don't know a ton about how to do it at that basic of a level, but really at a minimal level, like you can make biochar. You could make it in your backyard if you wanted to. Okay. And I know guys that do.
So it's just a small, it's almost like, the way I'm thinking about it right now, in like a wildfire sense, we did a bunch of wildfire podcasts, and it's similar to like a holdover fire. So a holdover fire is like, say you have a strike of lightning that hits a tree and there's no direct flame, but the roots, so there's obviously no oxygen down there, very minimal oxygen in the ground, right? The roots will start to burn and they'll smolder. They can smolder for over a year or more, right?
Yep.
So that's probably what's
similar.
Created.
Yeah, similar, I would imagine. Yeah, and that would totally be one of the ways that you could do it. I'd be really interested to find out more about how the Amazonians figured it out 2,500 years ago, because I'm sure. We have, we have a tendency to assume that people in the past don't know as much as we know, and I think that's probably incorrect in a lot of circumstances.
Oh, man, there's some interesting podcasts around that one too.
Yeah, absolutely. So I think that would be interesting to know. I've, of course, I'm looking at it from the larger scale. So a big issue right now, and kind of what my company is trying to do is figure out a way to produce reliable biochar in a continuous feed process.
Okay.
So rather than most of the commercially available technology that I'm aware of in North America for biochar production is based on like batch systems. So you fill up a kiln, You light it on fire, essentially start a fire somewhere in it, control that, and then let it sit for 24 hours. It burns, you set it, it cools, you empty it out, load the bin
so
back
a continuous process would make it way more efficient, way more cost effective.
Yeah. So like our process is essentially the easiest way to think about it would be as kind of like a Quiznos oven. So indirect
belt.
heat. Yeah, right. So you got a kind of a drag chain conveyor. You load that up with your wood biomass in an oxygen deprived environment, and then you're indirectly heating it from the top and bottom.
Okay.
You want to carry about 500 degrees Celsius. Like I said, that about 80 to 90 minute residence time. And then in our process, the syngas that's produced, essentially methane that comes off the wood material.
Yeah.
We have a proprietary syngas ejector system that creates a pressure differential using the Venturi effect, sucks that gas into our combustion chamber, and then ignites it with the propane burner.
Okay.
So when we're up to temperature, ideally what we want to get to is a point where we're running with enough syngas production that we don't have to use propane. The best I got to while I was operating in Drayton Valley was when we were up running, I could cut that propane consumption down to about 15% of what it was at startup.
That's so pretty sweet.
Pretty
so it's
good.
running itself almost at some point. That's the ultimate goal, I'm guessing.
The ultimate goal would be, essentially like a closed loop. Like
that's pretty sweet. If you could make that work, like that's a closed loop system that's
ideal. Yeah.
I mean, that's the ultimate goal for all those, renewable energies and renewable everything, right? Like it's
absolutely. And I mean, the upside of that, like it's not something that we're doing right now with our system. And of course, being, a demonstration kind of prototype, there's a number of things we could be doing that we aren't yet.
Yeah.
But we have looked at, combined heat and power, pulling off some of the thermal energy out of the stack that's just being emitted to atmosphere.
Yeah.
And there's a couple of things you could do with that right now in Alberta, because our natural gas prices are so low. Making electrical energy from it wouldn't make a whole lot of sense.
Gotcha.
But if you were in an area, say, by a concrete plant, or even by, a public works building that needed thermal energy, they had a large thermal energy load.
Yeah.
You could pull off some of that heat indirectly, provide that load. We've even looked at it, pulling some of that heat from the stack or from our flue coming off and piping it back into the process to let us control our temperature profile a bit better, or pump it into our hopper to actually dry some of the material going in.
Oh, that's sweet.
Yeah. We're not there yet, but it definitely something kind of got the wheels turning in terms of what we could do with some of that.
Takes time, man. Yeah, research and development, right?
Yeah, I wish someone had told me that like 4 years ago when I started doing this. Like, hey, stupid, this is going to take you forever. Maybe rework your plan here, because it's not going to happen quick. But yeah, no, it's... there's a lot of exciting stuff around it, and the the end uses for biochar are what's really exciting for me. Being able to manage our biomass, our residual biomass, and there's a huge amount of it sitting in Alberta.
Yeah, so like I'll just explain real quick. Sure, I'll just explain kind of what's going on there. So for those people that don't know, mills have a lot of residual biomass after they have created whatever wood product they're going to create. So there's sawdust from the saws. There's undersized stuff. There's all kinds of they wood chip some of it. They try to use as much as they can already. The mills are pretty efficient at using it as hog fuel, or using it as, sometimes they'll send it away to be turned into pellets for like pellet stoves and stuff like that. So they do use that byproduct, but they're always looking for new and easier ways to do it, because if they can sell it to someone like Chris, who can turn it into a useful product that might have a positive feedback loop as far as the carbon cycling and increasing productivity on the land base, that's huge. So yeah, so there's all kinds of residual biomass in the forest industry, and so that's interesting. I didn't know where you guys got your biomass from, but you did get it from a sawmill, so that's exactly what we're.
Yeah, it was it's the Weyerhaeuser sawmill in Drayton Valley.
Gotcha.
So they do. The Weyerhaeuser guys were great. Super supportive of us, and we're such a small scale. So like, to give you kind of an idea of how much they produce.
Yeah.
They on a yearly basis, and I don't have the exact numbers in front of me, but I remember through my conversations with guys running the plant out there, it was above 200,000 tons of residual biomass this year. So, which is massive.
Yeah.
And for our system, so my system engineered at say 3 tons per hour, operating throughout a full year. At best, we could get through maybe 6,000 or 7,000 tons of that material. So like crazy how much available biomass is there with.
And that's
systems.
One mill.
Yeah, and the Weyerhaeuser guys, the Weyerhaeuser guys in Drayton Valley, and you hit on it there. They're sending a lot of that material in the next year here to a pellet plant that's going up in Entwistle. So there's, they have obviously a desire to do something effective with that material, but
why waste it?
Yeah, and it's it's all kind of the cost benefit of how do you get this material to the right spot at the right price point.
Yeah.
One of the things, hopefully for us, that will be enticing as we kind of move further with the the carbon tax and the stuff that we have here in Alberta is that $30 a ton carbon tax can have a significant return for a site. One of the projects that I'm potentially working on is
just pull it just a little bit closer, another inch. There you go. Yeah.
One of the projects that my company's working on now is a potential site just outside Edmonton that would look at general waste diversion.
Okay.
And we'd be one component of that site.
Yeah.
Looking at the kind of the baseline greenhouse gas emission reduction from diverting your waste in general, and specifically looking at wood biomass for biochar production, we could offset about of the 20,000 tons of material that would run through the site each year, taking into account the fuel consumption and whatnot, we can offset about 17 to 18,000 CO2 equivalent tons at a baseline. So just landfill diversion, which at $30 a ton is almost $500,000 a year. So
it's nuts.
You get a lot of people are hard on the carbon tax, or forcing companies to spend more money isn't the best way to do it, but it's all incentive and de-incentivizing. So, if you're a company that has $1 million a year that you're spending in carbon tax, maybe look for a more innovative way to manage that cost, right? So hopefully that will continue to push people kind of into some of these more novel technology applications, which I guess we kind of fit into. So.
Well, why would we not want to, like the way I think about it, as far as the energy situation is concerned, like the easiest way to think about it, if you want to think about it from an economic perspective and not from an environmental perspective, take environment completely out of it. Yeah. Why would you want to depend on countries like Saudi Arabia to determine how much your energy is worth, or what your economy does? Why would you not invest in your own country, create all the additional renewable resources that you can for creating renewable energy? There's a million different ways you can do it, and then you're completely sustainable. It doesn't matter what Saudi Arabia decides to do or Russia decides to do. We're totally off the grid, and we can, no matter what those economies are doing outside of the world or outside of our country and the rest of the world, we're good to go.
Yeah,
that's just an economic argument. I can go into environment too, but we don't need to.
And I agree, and I think the idea that it's the way things have been done, so it's kind of the way we're gonna do things.
Well, it's the cheapest and easiest and most oil and gas is
in the
most
short term, like in the immediate, like it's already there. The infrastructure exists.
Well, and we owe who we are and what we are now to oil and gas, right? So it's something to be appreciated of, but it's also something that, like, if we can do better, why not do better?
Yeah, and I would totally agree, and I kind of have the same sentiment with just in general what we do with our oil and gas. I mean, we don't refine our own product here in Alberta.
There's that too, right? There's how many jobs are that, and how much profit is that we're missing out on, and
it's always the short term. Like this, it's going to cost too much in the short term. Well, I mean, if we take, a full LCA of what we're actually looking at in terms of economic cost, environmental costs, our future generations of what we're going to get out of the resources we have, the argument to not do this is nonsensical. It doesn't really add up. But if you look at it in a narrow window that, this quarter we're going to lose this amount of money. Well, yeah, sure. Like, if we're going to base everything we do off, 3 months to 3 months, then yeah, of course. But there's better options. And I think that ties into, the example of Saudi Arabia or the OPEC countries and what we have to do for oil. I mean, look at what's going on right now, with that hurricane down in Texas. It has an impact on our fuel prices, right? Yeah. So, we'd be better off, I think, in the long run, to again diversify how we get our energy and figure out more innovative ways to produce it and utilize the resources we have. Yeah, like we're super fortunate. Like I'm really happy to be Canadian and to be in Alberta.
Canada, we are such an awesome spot. Like
we have everything. Ridiculous. Like we got everything we need.
Water, energy,
and we've got a lot of smart people. We should really put a lot of emphasis on being able to utilize these things that we have here.
Yep. No, I'm right there with you. No, exactly. It's Yeah, it's odd that, I mean, oil and gas is always going to be there because, I mean, like, how many other things do we make out of oil? Like, I mean, half the
Totally.
stuff I'm recording on right now is plastic, so it comes from oil, right? So it's they're not saying oil is bad. We're saying, why would we not want to do better and reduce carbon emissions and have renewable energy and remove ourselves from the global energy problem and just be totally sustainable and do our own thing? Why would we not want to do that? So anyways, we're kind of getting off on a tangent away from biochar, but this is something I'm kind of passionate about, and I try hard to stay objective on this podcast and not bring in my own opinions, but it's tough.
It's tough not to. Yeah,
it's hard, especially because that's what we're passionate about, right? You want to keep going.
Well, and everything going on in the world, it's hard to not have an opinion about everything, I suppose.
Well, exactly. Yeah,
absolutely.
Anyways, so we haven't talked about you talked a little bit about byproducts with.
Yep.
So you said there's a syngas that comes off of it.
Yep.
And I read somewhere there's like an oil.
Yeah. So we don't condense no oil. You can call it a pyrolysis oil or a wood vinegar.
That's from the syngas. It's condensed?
Yeah.
Oh, okay.
So when you separate a material out, the reason why we utilize slow pyrolysis is because it gives you the highest portion of a solid product, so biochar, that comes out.
Gotcha.
So there's solid, liquid, and gas, and different ends of the spectrum for pyrolysis will produce different quantities of each liquid, gas, and solid. There are a lot of guys. There's a great company out of Quebec, Abertech, that specifically produces a liquid fuel, and they've got it. It's a different market out east, so they've got a good market for that. They produce a biochar. They don't really even market. They don't do anything with it because they don't really have the market out there for it.
Right.
So you could also there are some guys I know of that they try to utilize that syngas to produce electrical energy, in that capacity in a generator. We try to do our best to control keep the liquid in a gaseous state and keep it internally combusted. So in the combustion chamber, run it into the system.
Positive feedback.
And the simplest reason for that, and I mean, here in Edmonton, we've got a good example of how difficult it is to make biofuels, is the Enercam facility here in the city. So their goal was to take what's called refuse-derived fuel, so essentially MSW, regular garbage, plastic content with a high plastic content, and produce, essentially they want to get ethanol. So their first step is to produce a liquid methanol, and then upgrade that into an ethanol. That's been a very costly project or site that we have here in the city, and it's very difficult to produce a reliable fuel. One of the ways I had it explained to me was from an older guy that has kind of been trying to get a viable pyrolysis oil for the last 20 years.
Jeez.
And he said, sure, you can produce the oil, and even if it's semi-consistent, but who are you going to sell it to? Like, nobody with a vehicle who's insured or has, requirements, it's not a drop in fuel. They're not going to put that into their car. And, a lot of people talk about, well, we could, supply this, renewable or sustainable fuel to farmers. Good luck convincing a farmer to drop a fuel into his tank that, he can't guarantee he's going to work into his $500,000. It's not going to happen. They're not going to do that. So, for us anyways, it doesn't make a whole lot of sense to produce those biofuels. But with that said, there's a lot of research that goes on at the U of A, different types of biodiesels and stuff. That's a great industry, and that's something that I do think we should support. But in terms of what, my technology does, and my opinion of it is just that, the pyrolysis oils or the wood vinegar that comes out of the pyrolysis process isn't the best way to get, sustainable liquid fuel.
And who knows, it might be, right? It's just like every other renewable energy or possible renewable energy, right? Like it requires a societal change, right? We could all start driving electric cars today, but if all the electricity is created from coal burning, then what's the point? It's the same end result, right? So it needs a societal change. We all need to change as a whole, then in order for that to make any sense.
Yeah, and there definitely is a collective shift, and you see it in other countries. I mean, there are parts of the world where collectively they do decide, we want to encourage people to get electric vehicles.
Costa Rica, I think, I don't know about the electric vehicles, but Costa Rica, I think, was it last year or the year before, they were supposedly 100% like emissions free. I don't understand how that makes any sense, but apparently they figured it out.
I think a lot of the time when they say, like, when they'll...
Well, the equation is
yeah, so everything balances over the course of the year. Or you'll hear, like, Sweden had all of their energy from renewable resources for that day. And that's kind of the other part of the equation for renewable resources in general, is that, solar, wind, a lot of these technologies, they aren't dispatchable. So you have to be able to store them, right? Or you use them. And that's part of the issue with the way that our sustainable energy is produced here in Alberta, is that if you produce wind electricity, because you can't store it, you have to bid into the process at the lowest quantity.
Right.
So as soon as there's a demand, your energy gets sold first because you can't store it. So that's another part of the equation, and it's something, a company like Tesla's working on to get
those
better
power walls are pretty interesting.
Yeah, which is but again, you can get into the whole conversation of, okay, great, we get away from using petrochemicals to produce our energy and we start storing it in batteries. How long is it before we're fighting wars over lithium? We're fighting rare earth metals.
Rare earth metals are already a big problem. So
exactly. So that's, long term, that's maybe not the best solution. I think some of the opportunity may exist in, like nanoparticles and graphene. Graphene's a really interesting product that potentially could go a long way to making energy storage a lot easier. But all of those things kind of stack on one another. But specifically with, my technology and kind of what we're looking at doing, the main focus is there's so much biomass that we don't effectively utilize. And even right now, it's, for a lot of people, there's no other real viable option to even doing anything. There's no point in going out into the field and collecting any of it. We might as well just burn this because
they don't have the like forestry is not a super lucrative industry, right? So they don't have a lot of cash on hand to say build a new energy unit that takes that wood or that wood fiber and turns it into energy to run their plant, right? Like they don't have $3 million to build this because they just don't have that kind of money. It's not like oil and gas.
The margins are tight.
The margins are tight. So then they want to do it, but to pull it off and not tank the whole mill is tough to do. So they have the desire to do it, but the subsidies aren't there.
Well, and I mean, and that's the reality of it. Like in Drayton Valley, unfortunately, in the last year, there was a 10 megawatt biomass boiler plant out there at the Valley Power site that had to close down because they lost a subsidy that they'd been kind of relying on for 20 years. And, there's a lot of emphasis from the government for this, that, and the other. But those sorts of, support networks or, public funding that goes towards these things, we're kind of naive to think that a lot of the other large industries don't get that same support. Like oil and gas gets that support. Those subsidies exist for oil and gas. And, if you want to develop a new industry to compete, I mean, the barrier to entry to energy production is huge. Like if you want to compete with these other traditional forms of energy, you have to give more support to, to these companies. And it has to be in a more strategic way. I mean, a lot of the, the grant programs that I see and stuff, some of them apply well, to the development of the industry, but a lot of them are essentially funding research and development for large companies that already have, the money to do that.
Right.
So it's, the government has a lot of value here in Alberta for certain things, but in some situations, I kind of scratch my head like, well, just stop charging them a carbon tax and let those oil and gas companies pay their own money into research and development.
I can't imagine the number of things that the government has to try and deal with. It's like, how do you focus on any one thing, right? It's like, I can't even imagine how they get it done. But we haven't really talked about what the uses of biochar are. Like, so I read there's a whole bunch of litany of things that you can do with it. Yeah. So let's kind of get into kind of what those options are.
So, I guess kind of the lowest hanging fruit for biochar, probably what anybody who kind of knows what biochar is would hear first would be as a soil conditioner or a soil amendment. So if you break that down, it's not a fertilizer really in any sense. It's, again, kind of my way of explaining it to my buddies when they ask is it's like an empty hotel. It's a real porous structure. It's got a lot of space. It can absorb about 4 to 5 times its volume in liquid or gas.
Okay.
And you have to inoculate it with the hotel residents. So
gotcha.
one of the I did some or I didn't do them, but I supplied some of the biochar to do some plant pot trials in just outside of Drayton Valley over the summer here. And the young lady that was doing the work out there just the other week kind of gave me some feedback and said that the best blend we produced, or that she worked with, was a biochar mixed with some humic acid, which is a carbon rich product, but it's got a lot of microbial life in it.
Is that from humus, like from the
it's
derived from moss of some kind, the humus layer, not moss necessarily, but the humus layer, so the half decomposed part of the soil.
And I think you can also get some of it from a petrochemical application. I don't know enough about it to talk intelligently on it, but it's a carbon rich product. We get a liquid material, and it's got a lot of microbial life. So inoculating the biochar with that product, it works terrific. And that's kind of the value of biochar, is as, again, I guess the best term would be as a soil conditioner or an amendment. So that's kind of the I think the main thing probably that most people know biochar for. One of the other
potentially seeing like an increased productivity of the soil because of it.
Yeah.
Not as a fertilizer, but if you add it with other stuff, it's okay.
Gotcha. Yeah. And it's I think the best results, most reports that I've come across, the best results are for sandy soils, so really marginal soils.
Gotcha.
The biochar helps. It reduces. It holds everything. It reduces leachate. It helps with compaction of the soil, so it helps.
Right. You said it's like it creates space. So
exactly. And it gives that home for all of your microbial life and all the microorganisms that realistically are the best way to grow food.
Yeah.
In my limited understanding of how to grow food.
Yeah.
And then so I guess that would be kind of the lowest hanging fruit, or the most common application for biochar. Another significant application is as a food additive for cattle and livestock.
Okay.
So
literally putting the biochar into
their feed. Yeah. Okay. So like you or I could go into a health food store and get activated carbon to help with your digestion.
Same thing.
Very similar.
Okay.
Activated carbon is essentially a really high quality biochar in a sense. It's I think activated carbon is above 90% carbon.
Gotcha.
Or whatnot. So if you could produce a high enough quality biochar, it'd be comparable to what activated carbon is. So there's actually a study that just got funding in Lethbridge. The U of L is involved, and I think the cattle and livestock board or group may be involved.
Yeah.
But they just got I think a couple $1 million to do a feed study with the cattle down there, and the international results, I don't think any of these studies have been replicated in Canada, but the international results have shown that adding biochar, a small dose into their feed each day, actually has a dramatic effect on the amount of methane they emit through the digestive tract, which is a significant greenhouse gas contributor.
It's crazy how much cattle. It is. I don't remember how much, but it's like 30-40% or something supposedly.
Yeah, it's really high. Like the global you
can Google it, I guess. If you guys are listening, just Google it. How much of it's created from cow farts?
Yeah, exactly. So there's a huge quantity that comes out from their digestion, and it helps minimize that. It actually helps bulk the animals too. Okay. And the end fertilizer fields, the end fields that they're in are fertilized through their digestive tract. The carbon comes through them, and then it comes out essentially inoculated through the animal and ends up on the field and has some value there as well.
That sounds pretty amazing, because that's one of the biggest problems is, first of all, the methane release, like you said, is a huge problem with cattle that we have today. And then you're getting more biomass, I guess, out of the cow as well. So that's more yield from the beef. And then also, so if you're fertilizing the landscape at the same time, that's a huge problem that they have with cattle, is that they're stepping all over everything, and they kind of eventually they create loose soils, and that soil is eroded, and then that kind of spot is no longer fit for vegetation growth, and you can't have cows on there anymore. So that's a problem they have. And there's places in, I forget, somewhere in Africa and stuff like that, where they've had whole swaths of land that have been totally basically ruined because of cattle. Right. So if you can do the opposite of that and increase that soil fertility because their cattle are on there, that's crazy. You're getting all the good stuff. Yeah.
And again, you kind of, we circle back to, there's a collective shift that needs to be acknowledged from everybody. Yeah. So, I mean, if you're looking at cattle farms that have, high density cattle feedlots,
right?
really biochar is going to maybe reduce the emission of methane, but there's limited application there that's going to have a lot of benefit.
Gotcha.
But if you're looking at grazing animals and doing it in a more environmentally, conscientious way, then biochar can play a big part in that and can be a big benefit to that overall process.
That's sweet.
So beyond that, I know another one of the main applications for a lot of the guys, I believe out of the States, that are selling biochar is as an absorbent or a biofilter for heavy metals. So you can use it to filter out wastewater. You can use it as a filter for remediation sites. You can use it as an alternate daily cover or an absorbent on landfills to control some of the leachate that comes out.
Yeah, that was some of the stuff that I read, was that it was good for, supposedly it's a highly absorbent for chemical absorption or whatever, right? So it's good for spill sites and stuff like that. So if you had say you had a tanker that spilled over, would that be potentially? Yeah,
and that would be, for us, because I have one demonstration system and we're, even with that system operating, we're very small volumes. There are guys who are producing a lot larger volumes, and they would have more detailed conversations with potential oil and gas purchasers. Right. I'm nowhere close to being able to meet those volumes. So this is something I'm aware of, but I'm not actively pursuing.
Gotcha.
But that I do know for the guys who are producing larger commercial volumes out of the US, I think that's a number one application for them. So that, has a lot of benefit there as well. You can get into kind of the more novel applications. I know guys that have looked at, done some studies with biochar as a source material for graphene production.
Okay.
So like carbon nanotubes, just a two-dimensional arrangement of carbon molecules.
Okay.
If you have a carbon-rich product like biochar, you potentially can produce that product from that material.
Okay. And what's the uses of that?
Carbon nanotubes or graphene? I could go off on a whole nother tangent, but it's
that's all right. It's all good. We can do it.
It's got tensile strength equal to steel, stronger than steel. It's got zero electrical loss.
Oh wow! So it's okay. So it's a good conductor.
It's unbelievable conductor. It's unbelievably resilient. It just a whole litany of applications, and graphene, everything from bendable electronics to new types of transistors to nanotechnology, nanoscale battery storage.
Wow.
Yeah, graphene is definitely one of those wonder materials that if we can get a handle on how to produce it and use it effectively,
so just the general gist of it. How is it produced?
So
what's the base product that you start with?
There's a couple of different ways. And again, I probably bastardizing.
Yeah, we can just go quick. We don't have to say that you know exactly, but I'm just curious. I have no idea.
So the best, my understanding of it is that you take some sort of source material that has a high carbon content. I'll give you
a biomass.
The first one that I read was in 2004. These guys, I believe they were at MIT. They won the Nobel Prize for it. They essentially took graphite, so like a graphite pencil, and Scotch tape, and they put the Scotch tape on the graphite pencil, pulled it away, and they did that repeatedly until they got the graphene structure that naturally formed on the Scotch tape. That's how they first identified graphene. I know. I read it. I looked it up, and I was like, wow.
Such backyard science, but that's how...
Scotch tape? I don't know exactly the process of how they stumbled onto it, but that was initially how they did it. They got the Nobel Prize, and now people are doing everything from... I think there's an MIT study recently that's looking at filling a container with gas and then igniting it, and then you form a powder that's all graphene products. There's a number of other ways that it can be done, but again, similar in a sense to kind of where biochar is at. There's no real reliable production method for large quantities of graphene. So the guy that cracks that nut, whoever figures that out first, is going to be very wealthy, I would imagine.
It's a challenge for all you people out there.
Yeah, totally. And there's a number of different people. I know there's a company out of Edmonton, actually. They have a proprietary process for how they produce graphene. And I'm not sure how exactly they do it, but the term for how they actually go through that process is escaping me right now. But if you look it up online, it's a very interesting product.
Mm-hmm.
Outside of that, again, biochar can be used for, it can be an additive to composting. It can be used just in a general sense as an odor filter for landfill sites or composting facilities.
Right. Same thing. It's the absorption quality, I guess.
Yeah.
Right?
You can absorb 4 to 5 times your volume in liquid or gas. It's got cosmetic applications. So one thing that I actually saw a couple weeks back on my Facebook feed was people brushing their teeth with charcoal.
Yeah, I've seen that.
Right?
Is that legit?
And it removes the stains. The same
the
same idea. It's absorbing the stains off your teeth, I guess. And kind of
it's
removes
bad
everything.
for like enamel and stuff like that, though.
It can't be great. I feel like it would be pretty coarse, but
that's what I was thinking.
I would imagine that's an activated carbon type product,
Yeah.
but biochar, if it's got a high enough carbon content, could kind of serve that purpose as well.
Okay.
It can be used in concrete production as so when you make concrete, you have a portion of aggregate, a portion of cement, and a portion of what they call pozzolan, which helps to kind of like stick everything together.
Okay.
You can reduce the amount of cement and replace that, or reduce the amount of pozzolan and replace it with biochar, which has 2 positive environmental impacts. The carbon that you're putting into the concrete is locked up, so it's inert, so you're sequestering that carbon. And cement is one of the most carbon intensive processes.
Oh, it is.
It takes a massive amount of energy to get cement out of limestone and whatnot.
Mm-hmm.
So if you're reducing even by 10%,
helps.
You're reducing the amount of carbon that's required for that. So
yeah.
that's another application that there's not a lot of testing that's been done, but there's kind of novel applications there that could exist. And again, when I talk to people kind of about the potential applications for biochar, a lot of it kind of circles back to nobody really has a large volume of it available for people to work with. So
Right.
a lot of these kind of novel applications that could be really viable, but they take years of research, they take huge amounts of biochar, and is it something that people are going to push towards until we're at that point where we're producing large volumes? Probably not.
Right.
It's
who knows though, right? Like it's
I mean,
technology, we're always changing. We're changing so fast. Who knows what the next thing that comes out that might help the industry, right?
Totally. And I hope, and I've made this comparison sometimes. I hope that with the increased production capacity that I'm kind of seeing throughout North America for biochar, it's kind of akin to in the 19th century when we started pulling crude oil out of the ground. We used it to light kerosene lamps for 20 years, and
right.
didn't have any good application for it beyond that. And like you said earlier, now it's in everything, like every lacquer, every plastic. Like it's not just our energy source. Sure, we're going to get electrical cars. Well, how are we going to replace the petrochemical in the tires?
Yeah.
So kind of in the same sense, biochar, hopefully if we can continue to produce it and kind of get it into the market and make it available, a lot of people a lot smarter than me will come up with great ways to use it. So that's kind of, kind of my hope, I guess.
That's sweet.
Yeah.
So I'm going to kind of move into kind of the forestry side of it in a little bit slowly, but you were talking about like the soil fertility aspect of it, how it could potentially increase the productivity of the land base, right?
Mm-hmm.
Do you know, is there any effects on like the microbial community in that? Is there any studies on that? I read some things. It seems like the science is kind of out. It's such a new technology and nobody really is 100% on it, but I just thought I'd get your opinion.
Yeah. So you're totally right to say there's a lot of discontinuity in the studies that exist in terms of what the actual value of biochar is. You'll read things that'll say, in this situation, it had a marked improvement in the production capacity of the soil, or in this situation, it actually had a negative impact. So there's all sorts of things that go into that. Your pH levels.
Yeah, it depends on the situation.
Depends on the soil. Depends on the situation. Depends on what you're growing in the soil. And this is another thing that is difficult for the wider biochar community, is that in a lot of instances, we're not comparing apples to apples. People are taking a biochar that was made from a softwood lumber in a in a flash pyrolysis process, and they're applying it to this type of soil with this type of a crop that they're growing in it, and then they're making a comparison to another type of biochar that was made from a totally different feedstock in a totally different process in a totally different part of the world, producing a totally different crop. So I mean, that
it's hard to compare, right? There's not enough data.
Very difficult, and a big part of what's going on in the industry is that we're not really able. We don't have, I don't think at this point, a quality enough data set to make these comparisons accurately. Right. And it's a part of I guess a developing or a growing industry to try to get to that point. But I mean, there definitely are situations, and I've heard this from guys, out of the States and whatnot, where guys have applied biochar in mass without any inoculation or any blending, and it's ended up killing crops. So it can happen.
It has to be the right situation.
And you're very, you're definitely not doing yourselves any benefit by really not doing your homework or talking to a guy who's really well versed in the type of biochar they're using and how they suggest to apply it. One of the great kind of tidbits of information I was given was from his name's Merv Fisher, and he works with Humulite. And in the late 90s, his firm out of Edmonton, I believe they're Canadian Humulite International, he told me that they started kind of being the leader in terms of testing their material and quantifying data sets to show the value of their product. And he took a lot of heat in the late 90s because a lot of people in the industry, there were, for lack of a better term, snake oil salesmen selling stuff that they claimed had value that they didn't. And I would say that biochar is probably very similar in that space. There probably are some guys that would hear the stuff that I'm doing and say, well, this guy doesn't know what he's talking about. He's selling people. He's trying to hoodwink everyone. Right. But what Merv laid out for me was the only way that they got through the late 90s into the early 2000s to a point where people were satisfied with the quality of the humulite and the humic acid that they were producing was through this testing and this reiterative process and collecting those data sets. So, and now, last time I saw him 6 months ago, he told me, we're as busy as we could be. And he was in an office with, 20, 30 people running around. He's like, we couldn't take on any more business if we wanted to, because we've shown that we have a valued product that has a marked benefit in crop production. And again, the one anecdotal study that I know of that I put my biochar towards, the best blend was from a humic acid biochar blend. And that was compared with, I think we did a biochar manure blend, a biochar compost blend, and then a couple controls just to try to make the comparison. And it was a noticeable improvement that the humic acid had. So being able to quantify that, being able to collect that really valued data and make those apples to apples comparison goes a long way. But
that's how you do the science, and you find out the answers, right?
It's mandatory.
Repeat it.
It's so kind of to circle back to the question around different studies. There are studies that show that biochar works fantastic, and there are studies that show that biochar will kill your plants if you don't know what you're doing with it.
So you got to make sure that you do your your due diligence and make sure that the potentials are huge, but we still need to know exactly. We're still figuring out where exactly the application is, I guess.
For sure. And in the industry right now, and this is a part that hopefully my company can play moving into the future, is being able to really control or have some guarantee that the operating parameters are consistent. So for large purchasers of biochar, the worst thing in the world for them would be to get a really quality material that they sample and they test. Okay, this is great, and then the next batch is different, or the next batch was run with a different temperature at a different residence time with a different feedstock,
different qualities.
So, developing that continuity in the industry is a big part of that whole process of kind of validating the entire industry. But I mean, it's part of a developing industry, I think, and it's something that people who are selling shitty biochar, people who are touting things that they can't actually do, eventually they'll be found out. Eventually they'll be bucked. It's
in this market nowadays, man, you can't get away with a shitty product or bad service, or because the internet, man, it's impossible to dupe the internet. You can do it for a little bit, you might make a little bit of money, but eventually at some point you're going to be outed and you're going to be a snake oil salesman and people are going to be pissed. It's not going to be good for you.
Yeah, for sure. And I mean, we're for good and bad, I guess we're so connected in a lot of ways that Yeah, you're totally right. If you're not delivering what you're selling, or if you're you're trying to hoodwink people, eventually you're going to be in a bad spot trying to do that. So
yeah,
and I know that's been going on, the development of the industry over the last 20, 30 years. I know that's happened, and I know people have really been effective in their ability to kind of pick out the things that aren't working, and hopefully I'm getting the value from that from everybody that kind of came before me. But moving forward, it's definitely promising. But the different applications are certainly something that you need to hammer down and have that experimental data and be able to quantify.
Yeah,
all that
but it's
stuff.
coming up, so if you're it's definitely a possibility. And if you can get something like this, so it's a product that both sequesters carbons for, you said, potentially thousands of years, which is huge, right? And then also adds to like soil productivity and has chemical absorption qualities and has all of these things. Like you're creating positive feedback loops where you put this on the landscape, the carbon's already sequestered, you have more fertility, therefore you have plants and vegetation and trees growing better, therefore they're sequestering more carbon, therefore it's continual, right? So it's potentially an awesome product, and I'm excited to see where it ends up in the end here. But have you do you know of any uses, and like I know like you're getting the biomass from forestry companies, do you know of any potential research studies or anything like that going on where forest companies are using it on like forest land base and kind of trying to see its effects?
Off the top of my head, I don't.
Yeah,
I wouldn't be surprised if that was taking place, but I don't have any personal experience with that.
No, the only stuff I found online was stuff where people were using it on kind of farm trees, right? On lots where they're trying to grow a specific genetic stock or whatever, and same thing, right? It seemed to have a positive effect for the most part. And the ones I saw said that it had a positive effect, and it was worth the money, it was worth the risk. But yeah, it seems like there's no one using it on a forestry basis, which makes sense because we want to keep the natural world as natural as possible. And if there's an unknown, we don't want to add that unknown until we know for sure it's going to be good and not a bad thing, right?
And what I would say to that, it would be volumes. It would take large volumes to do that, even just to do a basic study to get your head around that.
Yeah.
And the volumes are tough to come by. I mean, right now, wholesale biochar throughout North America will sell for anywhere from, $600 a ton Canadian to $2,400 a ton, depending on who's producing it, the quality of it, and where you're getting it from. So, if you're looking at doing a research study where you need 10,000 tons to it's a huge cost. And if you don't know what the outcome is going to be, and, for a lot of these guys, you're probably waiting for somebody to kind of inch along in a more incremental way before you kind of go, okay, let's spend $6 million and see if this biochar is going to have a good impact. And I think that's, again, part of the, when I first started doing this a few years ago, it was a lot of the chicken or the egg. Do we need to get the technology to work first, or do we need to show that the biochar works first? So
the infinite argument.
I don't know. I'm gonna throw all my weight into seeing if I can get this technology to work, and we'll kind of go from there. But I mean, a lot of those studies that could be done, there's probably some limitation to how much volume they can get their hands on and what the cost is and stuff.
The technology, it's one of those things where you wait 10 or 15 years, and the technology might be at a point where you can do it better, cheaper, and it just makes more sense, right? And or who knows, but it's interesting. It's definitely an intriguing idea for sure.
Yeah, and I mean, kind of ties into even if you look at just renewable energy in general, it's like solar may be great for the next 5 years, but we may, crack that out on something else in 5 years that totally upends that entire, we figure out nuclear fusion. Well, then solar and wind don't matter.
We're going to figure out how to make a mini sun in a reactor.
If we do that, none of this other stuff really gives a shit. We don't need storage mediums anymore. Yeah. We've got nuclear fusion. Yeah. So, I mean, that kind of stuff, similar thing with biochar and kind of the thermal treatment of products. What I really think the value is, or not the only value, but one of the really key values is pyrolysis' ability to produce biochar from waste products.
Exactly. Yeah.
So, whether it's agriculture and forestry, whether it's the lumber industry, whether it's just general waste management, like if you're separating out clean wood material and you can produce a biochar from it, even if that biochar doesn't have a great application for a number of things, if it can be, one of the other applications that I didn't even mention that kind of flew out one ear, or in one ear and out the other earlier, was as a biocoal, like as a coal replacement.
Okay.
So the energy density of biochar is comparable to coal,
right?
And depending on your application, or your process for coal plants, you can potentially replace that with a biocoal product. So again, there's different guys working on different angles for those types of end applications, but being able to mitigate the greenhouse gas emissions that come from these waste materials, being able to reduce how much we end up landfilling material.
Yep.
And again, the biochar, it's great if you can sell it for a good return as a soil amendment or food additive or any of these other different applications. But even if all you end up doing is reducing it by 5 times its mass and using it as a cover on landfills, well, at least you don't have 5 times that amount of waste going into the landfill with all of the methane that's going to be, methane and carbon that's going to be emitted from it. So
the implications of that are huge. Like it's hard for people, I think, to conceptualize what that means, but it means it's huge implications. Like it means there's 5 times less carbon sequestered or carbon released, and there's 5 times more ability to store.
Yeah. Your landfills, your airspace is saved, and I mean, waste is ubiquitous through any there's no culture or community that's ever existed where they don't produce waste. We're always going to have that problem. And again, kind of harping back on renewable energy and kind of the sustainable path forward, it's identifying these connections that is the most value. So again, if all pyrolysis can do is take clean wood waste or semi-clean biomass and reduce it by volume and mass into less product and land apply it without the carbon emissions, that's terrific. That's a step in the right direction.
That's huge. Yeah.
So maybe it's tougher to monetize all of that, so I'm going to still keep trying to produce enough of it to sell. Kind of on the whole, there's a lot of value there, and it's something that can be done. And like, honest to God, like my system is in terms of continuous feed pyrolysis process producing biochar, it is kind of pushing the edge of what exists in the market now. It's not dramatically complicated. Like I'm not a rocket scientist. I'm like, I've got a communications degree of all things. So like I'm not that smart that I figured something else out that nobody else could figure out. It is a viable process that has a viable application in a lot of areas. But again, kind of to your earlier point, there's got to be a bit of a shift collectively from society to say this is something we want to emphasize. Yeah. And this is something that has value, but whether we make it work or not, all depends kind of on how we're going to approach it, I guess.
Yeah, exactly. I just had a thought about the replacing coal, right? And some people might be like, well, what the hell is the difference? You're still releasing the carbon back in the atmosphere when you're burning it. It's like, well, the difference is you're not removing carbon that's stored in the ground as coal and releasing that. Whereas that is literally adding to the system. Whereas if you're taking carbon that already exists in the system and reburning it, it's carbon neutral. It's net equal. It's not.
And that's the case that pellets make a lot. Right. Is that you're not pulling it out of the ground.
Exactly.
And I think there's a limit to that. Right. To an extent, but again, for us, even just what goes into actually mining coal out of the ground. That's when you look at, and I said it earlier, and maybe I should have clarified, when you look at life cycle assessments, so how much carbon is emitted or how many greenhouse gases are emitted, it's like any software program, it's garbage in, garbage out. So if you don't account for everything, then your evidence or your conclusion is going to be off. So same thing with coal. there is value to having a coal replacement, but you gotta quantify all that to show the value. And that's the same thing with when you talk about
you have to prove it.
Yeah, you have to be able to show, and there is people who are skeptical, like, fuck, be skeptical. Like, being skeptical is great. Like, if you think a biocoal replacement or even co-firing with wood pellets or whatever in coal plants isn't a good way to get rid of coal, then by all means, like, make that statement, like, challenge that. Like, we're worse off just blindly accepting things, and I think we're only going to really progress by having those conversations and putting effort into, again, the research and the science. It's the scientific method's so great because it can change, like,
constantly adapting.
Like, you can tell me that gravity exists, but if somebody shows me that it's actually the moon pushing us down and there's scientific evidence to quantify that, then, like, well, shit, I was wrong. Gravity isn't a thing.
It's a flat Earth. We're on top of turtles.
Totally.
Turtles all the way down.
So that's the great thing about the scientific method. And I think we should rigorously apply it to pretty much everything we do. So, challenging whether biochar's application as a coal replacement is a good idea. Fuck, by all means.
Yeah, that's awesome. It's just, the applications here, it seem the potential applications are pretty endless. It seems to keep going, and we just need the science to back it up to make sure that it's going to be what we think it's going to be. So that's awesome. One other question regarding the forest industry, if it turns out that it was going to be in certain situations, maybe it's perfect for regrowing pine, right? Because they're generally on nutrient poor soils, kind of sandier, so they might be perfect for that kind of situation. Do you think there's a way that you could create that on, like, instead of bringing it off the land base and then bringing it back to the land base, like from a cut block back to a mill and then back to the cut block, is there a way that you could bring that pyrolysis process to the cut block and do it on the spot and then just distribute it there?
Yeah, so our system,
I was thinking maybe, like, even just, like, is there a way to manage a burn, like a prescribed burn, so that you could reduce the oxygen content?
I think you probably could do that. I think it would be pretty difficult to do effectively. And I only say that because I don't know of anyone who's effectively doing it.
Right.
So I haven't looked into it enough. So maybe it does, or maybe there is somebody doing it and I'm not aware of it. But so I think you probably could. But for us, in terms of, like, what my system does, the system that we have in Drayton Valley is a pretty big system. It's about 50 tons and sits on a large skid. Takes up, with storage and everything, about an acre of space. But what we have some of the engineering work done around is a scaled down system that would sit on a 53-foot step deck trailer.
There you go.
So lower throughput, less production capacity, but that with a generator and everything built into it, you could take that right out into the site, potentially harvest your material, mulch everything, run it through our process, and then land apply that biochar. So maybe a little bit further in terms of technological development, rather than just a slash and burn scenario where you're out in the field doing it. But again, I think with the right amount of research and the right amount of understanding, I think there probably are a lot of guys, given the opportunity, they could figure out a way to effectively do something along those lines. And again, right now, without the evidence to back it up, there's still a big question mark of, would it really have a benefit? So without an answer to that, nobody's going to really take the opportunity to do it, because who the hell knows if it's going to have any benefit or not. But there definitely is a potential for that kind of application, and that's the logistics around just moving biomass out of the bush is so costly.
It's so costly. Right? And in my mind, I had this, like, kind of cartoonish idea of, like, so people that don't know all the waste that's on the cut block that can't be, they leave a lot of it for the biomass to kind of decompose and come back into the soil, right? But a lot of it's too much, and it reduces ungulates' abilities to cross, animals' abilities to cross. So you want to get rid of a lot of the heavier, bigger stuff that's useless, and they end up burning it on the cut block. So I have in my mind, I have this cartoon idea of, you have this pile of debris, woody debris that's going to get burnt anyways, right? Can you just get a cover and just, like, put it on top of that thing and potentially just reduce the oxygen amount enough that you get some kind of, I don't know, this is just me thinking out loud, right? But
I think there probably could be an application like that. Again, there are probably guys who would be way better qualified to speak to that than I would. again, from my angle, the way I would look at that would be, look at getting a mobile system that can come closer to site, if not right to site, and then, in a continuous feed process, produce that biochar and land apply it. That's doable. That's doable right now. Realistically, it would be very difficult in certain areas to get in and out.
Well,
I mean, of
access,
course,
because it's
just the
such
access,
a long distance.
Yeah. So I mean, there of course is complexity to that, but in the right scenario, you could show that works now. But again, there's I'm sure there are there may be some people listening to this who know more than I do, kind of banging their head off the wall. Like,
that's
not doable. Shut up. But again, these are the sorts of things where, because everything's so underdeveloped at this point in terms of the industry, there's a potential application for all sorts of things that we really just haven't come across yet. We haven't really crossed that bridge yet.
Yeah. So. Well, it's an awesome technology. I'm excited to just kind of see where that technology goes. I'm going to keep a lot closer eye on it from now on, for sure. That's pretty much, I think we got through the listening questions. That's an hour. So that's kind of what I'm aiming for with the podcast.
Perfect.
Do you got any final thoughts? Anything you want to kind of add in there?
No. I mean, just in the general sense, I think we're all better off to be open-minded to new ideas. And, you get a lot of pushback from people who don't want to change the way we've always done things. I remember in the alternative energy program, I had a great class with our instructor had been doing geothermal projects all over the world for a long time. And he was describing how high the efficiency was in geothermal applications and how great it was and this, that, and the other. And I kind of raised my hand, naively at the end of the class and was like, so why don't any of our, how come I don't know anything about this? Why don't any of our classes do this? And he started laughing and smiled at me and said, because it's the way we've always done it. Yeah. And, that crystallized for me a lot of the idea of don't be so adverse to changing the way we do things. Don't change the way we do things just because you want to.
Yeah. Challenge
it, have the research, have the evidence. But, when we get a good idea, pursue it.
Why not, right? People are all worried about, I'm going to lose my job because of this technology. It's but creating that new technology creates so many more new jobs.
Totally.
So you need to go and get an education and get those skills. So you're it's not like you're losing jobs. You're actually probably gaining jobs, I would argue, because the technology is so unknown and we need more people to learn about it.
It takes more time.
But they're different.
It takes more involvement.
So the trades have to change for that matter, right?
Yeah, and I think a guy who's skilled in one area doing something, whether it's harvesting biomass, whether it's farming, whether it's this, whether it's that, my buddies who are skilled with their hands, I could put them in any situation, they could figure out how to do it. Yeah. So create solutions to these problems that we have, and don't shy away from taking risks to do things. I mean, I started doing this at a pretty young age, and hopefully I don't have to file bankruptcy anytime in the near future. But I definitely can see that there's hesitation from people sometimes to not take these risks, and I think some of the best advances we've had in our lifetime, or really for humanity, have come from people taking really, really crazy risks or really novel approaches to things. And right now, I think we're at this point where we got to make steps towards changing the way our energy is produced, changing the way we utilize the materials we have, and doing it in an innovative and an environmentally and economically conscious way. Yeah. And I don't think the two are mutually exclusive. I think you can be environmentally conservative, and I think you can make a lot of money. And I think that, again, a guy like Elon Musk and Tesla, they prove that.
Exactly.
It's the fastest selling vehicle ever.
Yeah.
People want that, and you don't have to have the two things separated from one another. So being able to take that risk and push these innovations when we see them is something that I would encourage anybody listening to this to do.
Yeah, well, you have to put your neck out there, right? Put your ego on the table, and
totally,
you know what I mean? Everyone walks around thinking that they know what's best, but if you really know, put your neck out there and prove it, right? So
yeah, being told you're wrong and then being able to prove that you weren't wrong is super satisfying.
Yeah, exactly.
It's good to be challenged and be able to defend yourself, man. Yeah, for sure.
That's awesome. Well, this is awesome. I'm really glad I brought you on. This was
Yeah.
I think it was
Thanks
just
for having
pretty
me, man.
informative, and it was
Yeah,
really good. People
yeah.
are gonna like it, I think. So
Yeah, absolutely. And in the future, as we have some more developments, I'd love to come back.
I'd love to have you back on,
Yeah,
even
man.
to talk about other things. Get more into maybe renewable energies and
I'll,
kind of all other stuff, right?
I'll do some a write up on graphene, and I'll explain.
Yeah, there
that
you go.
better next
Graphene. Yeah, no, that's an interesting one too, right? That's cool.
Yeah,
Awesome.
absolutely. All right,
Right on.
thanks a lot, man.
Yeah, thanks a lot. So anybody who have any questions for me or Chris, I can direct them to him. Yourforestpodcast@gmail.com. And yeah, thanks for listening, guys. We'll see you next time.